Research investigating the effects of amino acids in growing and finishing beef cattle is not a new topic. Many studies suggest that in cattle fed, a concentrate-based diet, lysine is the most limiting amino acid followed by methionine. When considering supplementing amino acids to growing, finishing beef cattle, the amino acids must be protected from ruminal microbial consumption for the beef animal to be able to absorb the amino acids in the small intestine. The amino acids must be protected from ruminal microbial consumption for beef cattle to be able to absorb the amino acids in the small intestine. The regulation of skeletal muscle growth is multifaceted, complex process controlled through many signaling cascades. One major process involved in muscle growth is the mammalian target of rapamycin signaling pathway. The objectives of these studies were to investigate the role of encapsulated methionine on feedlot growth performance and carcass characteristics, and to elucidate the role of methionine supplementation on the mTOR signaling pathway and skeletal muscle development in feedlot stress during the finishing phase. When considering supplementing amino acids to growing, finishing beef cattle, the amino acids must be protected from ruminal microbial consumption for the beef cattle to be able to absorb the amino acids in the small intestine. The regulation of skeletal muscle growth is multifaceted, complex process controlled, complex process controlled through many signaling cascades. Complex process controlled through many signaling cascades. One major process involved in muscle growth. One biggest reason is that is the biggest reason. The facility is new. Better means recently built. 60 years, 50 years, so newly built. So you are, this is a larger, clean. There is no resource. It's a bigger. We need 1,000. If you only one major process involved in muscle growth. One major process involved in muscle growth is mammalian target of rapamycin signaling pathway. The objectives of these studies were to investigate the role of encapsulated methionine on feed growth, performance, and carcass characteristics, and to elucidate the role of methionine on the mTOR signaling pathway and skeletal muscle development in feedlot steers during the finishing phase. Abstract. 2 studies were conducted to evaluate the effect of encapsulated methionine on live performance, carcass characteristics, and skeletal muscle development in feed steers. In experiment 1, 128 crossbred steers were used in a randomized complete block design and supplemented with 0, 4, 8, or 12 gram per head day of luminally protected methionine for 111 days or 139 days. Supplemented 0, 4, 8, 12 grams. In experiment 2, 20 steers were stratified by body weight and randomly assigned to either the 0 methionine or 8 methionine treatment. Longissimus muscle biopsies were collected and day 0, 14, 28, 42, and 56 and analyzed for mRNA and protein expression. Additionally, immunohistochemical analysis was performed to measure fiber type, area, and distribution, as well as the density of muscle, nuclear, and satellite cells. In experiment 1, no significant differences were observed for live performance. There was, however, a linear relationship between longissimus muscle area and methionine supplementation, with a 9% increase in the area steers were supplemented with 12 methionine compared to 0 methionine. In experiment 2, there were no treatment X-days interactions for expression of mRNA or protein abundance. Although mRNA expression and protein abundance of all genes were influenced by day, methionine supplementation did not have a significant effect. Methionine supplementation did not have a significant effect. There was a significant treatment X-day interaction for distribution of MHC1 fibers, where 8 methionine supplemented cattle had a greater proportion of MHC1 fibers after 56 days of supplementation than did 0 methionine steers. Cross-sectional area was increased over time regardless of fiber type, but was unaffected by treatment. While nuclei density was not impacted by treatment, the density of myonuclei increased nearly 55% in 8 methionine supplemented cattle. The density of MIF5 positive positive satellite cells tended to decrease with methionine supplementation, while the density of PAX7 expressing cells tend to increase. These results indicate that encapsulated methionine supplementation may influence markers of skeletal muscle growth and potential improvement of longimanous muscle area may exist. Methionine. Animal and Food Science, Texas Tech University, Camin Industry, Methionine, Department of Animal Science, South Dakota State, correspondent. They are preparing, hiring a new person.